Hello, Aadharsh.
Hi, Rob.
This is a special episode of Silicon Economics. We're just going to take a couple minutes here. It's going to be a short episode, but I know we wanted to address some of the top questions that have come out of the new Era of NAND podcast. For those of you that haven't seen the new Era of NAND podcast, you should stop this podcast, go on the WDC.com website, go under Investor Relations, and you can see the new Era of NAND content. But in that new Era of NAND content, we said some controversial things. And I think for anybody in this industry that's been here for a long time, one of the most controversial things we said was the layers race is over. And as I've been out, talking to customers and partners and even employees, people have graded that with skepticism. Like,
Right.
what do you mean? I hear about people announcing more layers. It sure seems like things are continuing. So how would you help people understand, unpack why do we say that layers race is over, and what does it really mean?
Yeah, when we say the end of the layers race, we actually talk about it from a more holistic sense from economic angle, right? Like we're not talking about technology progression as is.
Right. We can build more layers.
Yeah, we're going to build more
We
layers.
will build more layers.
Yes.
Yeah.
And we are definitely going to go search nodes that have more layers as long as it has value to our customers, right? Like, and the main thesis about the end of the layers race is if we take layers as a myopic vector with which we are going to try and search for nodes, that is no longer supported by the economic thesis as we see it play out. The idea is quite simple. Like when we think about how the layers are actually forming to be useful to our customers, there's like the supply side and then there's the demand side. If you look at the supply side, obviously adding more capital gives us a newer nodal migration, which often tends to have new layers, sometimes may have additional technology innovation vectors that are beyond layers. And each one of them are accretive to some new feature. And then we also sometimes tend to get cost reductions, but we are at least able to squeeze more bits very often, right, onto the wafer. And so that's the supply side of the economics that leads to us growing the bits, which is the most important thing, which is there's a bit growth. Now we'll have to work that cycle in the reverse for the demand side, and both of them have to be in equilibrium, which is where the new era of NAND is coming to be. So when you work it out in reverse, the bit growth would actually have to translate into margin growth, and that margin growth gets reinvested for us as a provider, and that serves the new capital going in.
That's how the economic machine works.
That's how the economic machine works. So when you follow this incentive structure, what we are essentially saying is that one technology vector of layers is probably no longer the only thing that you can use to scale. You'd have to think more holistically and you would have to operate more holistically.
Well, I also think the simple-minded idea that a manufacturer can simply invest more capital in more layers and then generate enough price response off the cost savings to consume those bits, that's changed.
Yes. The fundamental thesis of how the market has operated with the price response of the customer has come to be questioned in the 3D era, right? Like that. This is a new technology that all of us obtained. In the 2D era, you could cut prices and pass through all those all those cost savings. Sorry, you'd cut costs, pass through those costs as price saving to the customer, and then essentially get the customer to buy more. That dynamics is no longer holding true in the 3D era, right? Like you can't have as much cost reduction be passed through and invoke the customer to go buy more. So for us as a supplier, we would have to really rethink how we invest capitals and how that kind of plays out in the market from the demand response.
Yeah, the 256 gig phone for the price of a 128 gig phone is just super easy to sell. The 256 gig phone for 1.5, 1.6, 1.7 times more than that 128 gig phone, that's a really different value proposition. It's just not going to generate the same demand response.
Absolutely. And of course, something might change this equation. Like if the customers truly want more NAND, right? Like maybe like there is a co-evolution in this ecosystem. We've spoken about this in depth where if you kind of think about it, the cost of storing a larger and a larger photograph was brought down on your phone because of the NAND industry. Now, if you are having something that is going to require that kind of a large capacity and the customers are willing to pay, say AI workload generates a lot of content on the edge device and you want to store it on the edge device, and that requires a larger storage, maybe the customer is willing to pay that 1.7, 1.8 in the calculus that you are outlining.
They need it.
Yeah, they need it.
Right.
At that point in time, of course, things would change and that will work flow backwards into the machine and the capital would get invested.
Right.
But the incentive has to align.
So this is something we didn't really get into, which is organic growth.
Yes.
Like organic growth really it changes this entire equation. And so when you have an organically growing market like AI, the AI data center and the AI data cycle right now, that changes the economic equation fundamentally.
Absolutely. And we see this in different markets, right? Like if I told you tomorrow, guess what, Rob? If you can take 10 gallons of orange juice, you can get 1 gram of gold from it. We're all going to run to the Kroger supermarket and stock up on orange juice. So something like that, where there is a fundamental need or like an economic value that is getting generated upstream that drives the downstream investment would definitely change the investment dynamics. But we also have to understand that our market is segmented. So we have, like the NAND flash devices, we have things in the data center, we have things in automotive. So it's like a very complex market when it comes to understanding the aggregate price response. And part of our role is to basically create quantitative estimates of all these price responses and solve for what's optimal for us.
And this leads directly to this idea of a multi-node world. In that if I'm just simple math, if I'm not moving from node to node as fast as I was previously, then there's going to be more nodes in the fab. And then the question is, well, how should those nodes be deployed in the marketplace against all those segments and use cases you talked about?
Right. I mean, this is a classic problem in capital allocation that is there in several industries, right? Like the cloud industry as a great example. When a new generation processor comes, it's not like they are going to replace the entire data center in one go, right? Like that'll be, to say the least, a ridiculous use of capital. So the right way to sort of do that would be to try and understand what are the workloads and how they can benefit from the new generation of compute that is coming about. So there is a gradual sort of migration of the capacity of the cloud, if you may, onto the new nodes and onto the new generation of compute. I see a similar parallel coming to our industry where I think there is going to be a feature-driven investment where not all of the fab needs to go to the next generation node for us. We would gradually sort of migrate, and in some of those circumstances, we would benefit from the newer node having advanced features, and perhaps it could even work out so that the older node becomes cheaper simply because of the average cost or average capital dynamics, which would be the future in a multi-nodal fab.
Yeah, well, I think the cloud use case is great because when that latest and greatest technology, the latest NVIDIA GPU is deployed, it's deployed as a premium use case.
Yes.
Right. It's how most markets work. The technology is better, faster, higher capacity, gets deployed into a premium swim lane, and the older technologies get deployed into more value swim lanes.
Absolutely, and that going back to the supply-demand balance, right? Like when new capital is going in, the first part where the capital would actually have to be put to work are places where we can get a lot of returns. And so quite naturally, it makes more sense for us to deploy to a premium or like a performance swim lane, as we like to call it inside. And then once we've kind of obtained a flow from that capital, and when we are having future nodal migrations, it would go to the more value swim lane. And classically, when we think about economics, demand equations, we tend to draw price on the y-axis and quantity on the x-axis, and the downward sloping curve in itself talks about high value use cases or high value consumption happening at a premium price first, and then that navigating down to more low value cases, and that's just the economics playing out.
So I think from a customer perspective, the interesting is for the customers that have a choice, and some of our customers are perfectly happy. In fact, they don't want us to move a node. An automaker being an example, they want to sit on that same product for 10 years. So they're actually asking for continuity of node. There are other customers that clearly have specific requirements where they need the latest technology. Generating high capacity, using high capacity QLC for AI data lakes absolutely requires the most dense, the newest technology. But then there's a bunch of customers in the middle who have choices about which of these technologies they may want to deploy. And historically in the market, those customers have felt that latest technology was going to be the lowest cost because that had the most ample supply. I think our thesis going in is that that equation changes where that premium product, that latest node, is going into those performance use cases. And you, as maybe a value consumer, you don't want to be bidding against those performance applications. You're going to lose that auction.
Yeah, there is. I like the way you phrased it. I think there is like these 4 vectors that customers kind of have to play around, right? Like price, performance, capacity, and value. Now the question is, on those 4 vectors, where do you land in your use case? As an automotive customer, as you kind of outlined, they value some continuity in the node. They want their supplier ecosystem to be rich. They've understood the node. They want it to like last longer. Whereas like there may be an AI data center application where it's like straight up, get to the fastest one, you're throttling my GPU. And so customers really have to think, okay, if I have to gain one, what is the trade-off that I'm giving in terms of that price, performance, power, value trade-off?
Well, this sort of leads directly to the other side of the new era of NAND. The new era of NAND implies that we're moving from this sort of myopic focus on cost and elasticity or price-induced demand as a primary driver of the industry to a focus on features and capabilities, right? What value we provide. And so what do you see, what's happening in that dynamic? What are those features and capabilities that customers care about?
Yeah, so we've tried to study some of this, and we're in the process of studying some of this. So we don't have quantitative estimates yet, but we have a qualitative assessment of what's happening. It's obvious to us that the new vectors of innovation are emerging. And I think we've spoken about this in the new era of NAND.
It's performance, power, capacity.
Exactly, yeah. And all 3 of them have inherent trade-offs. Some of it just comes down to the physics, right? Like, for example, if you have a QLC drive, that is like fitting 4 or 16 in some cases, depending on how you do
levels,
the math.
Yeah,
levels. You have the 4 bits per cell. And in theory, you're actually doing a sequence and then you're fitting 16. Anyways, the technicality aside, there you cannot simply deliver some of the performance implications, or like it's going to have a different trade-off to the other vectors. And so inherently, that equation needs balancing from the customer point of view.
Well, in fact, there's a great analogy here, because this exact phenomena we're talking about just happened in DRAM. Right. So DRAM went in the early 2010s. DRAM nodal migration slowed from that Moore's Law 18-month, 24-month type time frame to a multi-year migration. And at the same time, the DRAM manufacturers started to optimize. And the DRAM that's in your mobile device is different than the DRAM that's in your PC, which is different than the DRAM that's in your GPU. And in fact, if you look at what are the vectors they optimized around, no surprise, it's performance, power, and capacity.
Right. The clear case of segmentation in this market is good for the market, and it's going to generate a lot of value.
And another question that I think, or misunderstanding maybe in the market, is really even the role of the NAND versus the role of the system and the controller and disentangling, well, what is it that actually delivers the goods? When I look at the performance of the devices, these devices are very, very strange devices, have very strange characteristics. But with controller innovation on top of those devices, then you can actually deliver those end user capabilities that people are asking for.
Yeah, it is. It's like NAND is just a raw material in one sense for our a downstream system or like a component that we build on top of it. And we are also a consumer player. So we actually deliver value where literally somebody can buy an SSD and plug it into their laptop. And that SSD has a NAND in it. But ultimately, I have seen zero customers wake up in the morning and ask, oh, I need a 32 GB pen drive, or like I need a 1 terabyte SSD. I wonder how many layers the NAND in it has. They just straight up go to say, okay, is it going to meet my workload? Can I transfer like a 4K video swiftly from my computer onto the device, and can I back up my photo shoot from my iPhone? So those are the kind of questions and problems that they are trying to solve. And so you're spot on in sort of your observation that there's enough heterogeneity and segmentation in this market that we have to kind of think of NAND as a mechanism to meet those needs and not as the driving factor of those needs.
So, Aadharsh, I want to geek out here from an econ perspective for a moment, because as you've educated me, there's really two kinds of markets out there. There's markets in which you, as a producer, you think about the volume you aim to produce, and there's markets that you think about price. So help me frame out, how does the NAND market fit in that economic framework?
Yeah, great question, Rob. Thank you for that. So we are what I would call a quantity setting market, right? Like, so we actually, we don't wake up, rather, let me give an example that some of our listeners and viewers would understand. We're like similar to an oil market as an example. No oil industry wakes up and saying, I'm going to set the oil price at $3.50 a gallon. They can't do that.
Right.
What they can do is they can say, how much oil am I going to produce?
Right.
And then they produce the oil, they let the supply go into the market, and then the market determines the price. So we're similar, right? Like we choose how much bit growth to target. We have our fab, we have our capital investments. And so our incentive as WD is to actually figure out what is the optimal quantity that we are going to produce for our company. And then downstream, those quantities get realized as prices. And if we have a revenue and a margin growth from that, we actually have additional capital to go reinvest. So this kind of a market setup where the participants actually try to determine the quantity is known as a Carnot equilibrium. And there is another kind of equilibrium, as you call it, where the participants actually determine the price. So they could say, I'm not going to sell below this price. That they make a conditional sale on the price. So that is a price-based equilibrium, and we call it Bertrand equilibrium. I feel like we are a market that is a lot more towards the quantity setting, where we actually tend to determine how much supply goes into the market as a provider, and then the market gives us a feedback.
Right. If I'm an oil company, I decide how much capital to invest in drilling and exploration and building capability. And then I provide that supply out to the marketplace, and that generates my return on capital.
Yeah, and they also get a market feedback, right? Like, so let's say if oil is doing like $8 or $9 a gallon, obviously then offshore oil fields, which were not profitable earlier, would become profitable suddenly. So you would actually see some of those deep sea exploration start, or like you'd see deep sea oil fields kind of prop up. So it's very similar in that sense. If you have to tie it back to some of the discussion that we had, if customers truly value the next node, which has got more layers, but it's got more performance, but is also capital intensive, that's their feedback to us, to basically say, yes, this is actually a useful thing for the society.
But now this starts to explain why this industry is so challenging, because you're telling me I have to make a decision pretty far in advance about how much capital to invest to deliver that demand. And what is that for a typical manufacturer like us today?
Yeah, this is there's a reason why, like we have all the computational elements of economics and why I enjoy the role, because we kind of have like a way wherein if we kind of deploy too much capital upfront, and I think it depends on the lead time, because we'll have to get equipment from the wafer fab. And
it's about a year, right?
At the year at the very least.
At the very least, minimum a year.
Minimum a year, right? Because we have to set the supply maybe even 2-3 years in advance in some cases.
You have to build a building.
We have to build clean room space. There are constraints that come, like there is electricity contract, what have you, right? which makes it interesting.
So I have to accurately forecast what I think is going to happen in the market 1 to 3 years from now.
Yes, and if you
to do my job,
to do our job.
Actually, you have to do it to do my job.
Yeah, I'm at the quantitative end of it. Yeah. So, like, if we overinvest, then that means we are actually going to have a market downstream where the prices are going to be suppressed, and we wouldn't get enough good feedback from the market or enough profitability from the market. If we underinvest, we are actually missing out on opportunities. So it's like a very fine needle that we'll have to kind of constantly reevaluate. And that's the reason why we want to digitize a lot of this.
Yeah, so I think, in high school econ, the problem's simple, right? We have this supply and demand curve. We can just sort of move up and down. We can let this thing settle out. Here in the real world, much more complicated, much harder to get this right.
It's a stochastic demand optimization in one sense, because we don't know what the demand is going to be downstream. We know there is going to be growth, and there is also a little bit of organic versus inorganic growth. So all of this has to be factored in, and it's a dynamic game.
And we have new application. AI pops up
yes.
out of nowhere and generates new demand, or the iPhone or whatever the new application is.
The good thing, though, is we have the technology capability as a company to optimize across different portfolio of products, right? Like, so we serve a broad enough swath of market that the way we've kind of outlined this is we'll make our portfolio robust to various outcomes downstream, such that if one of those outcomes materializes downstream, we can actually, allocate a lot more of our NAND to a more profitable portion of our business.
Well, then it seems like if you're a business decision maker running one of these businesses, what you need to think about is sort of what's the benefit of being right and what's the cost of being wrong, and does that induce you to be more conservative or more aggressive in your decision making?
Yeah, there is a classic set of problems that are in the intersection of operational research and econ, with economics, when it comes to this newspaper vendor problem, right? Like, where you have to kind of figure out what is the inventory position that you take without knowing what your demand is. Those flavors work backwards into our quantitative systems. So your intuition there is spot on, and your observation is super astute in saying that's how we think about it, which is what's the cost of being wrong on either of those ends? And we want to kind of minimize the cost on both ends.
Well, Aadharsh, I could talk about this forever, but we promised to make this a quick hit Silicon Economics. So thanks for sharing your thoughts.
No, thank you for asking these thought-provoking questions.
Thank you for joining us for today's episode. If you enjoyed it, like, share, and subscribe. And we're always looking forward to hearing your feedback. And be on the lookout for the next episode of Silicon Economics.